So I'm doing problem number 55. A commuter train travels between two downtown stations. Because the stations are only 1 kilometer apart, the train never reaches its maximum possible cruising speed. During rush hour, the engineer minimizes the time interval delta t between two stations by accelerating for a time interval delta t1 at a rate a1 is equal to 0.1 meters per second squared, and then immediately braking with acceleration a2 is equal to negative 0.5 meters per second squared for a time interval delta t2. Find the minimum time interval of travel delta t and the time interval delta t1. So we basically have two travel segments. One we just call it x1. We call it distance x1, which the train travels at an acceleration of 0.1 meters per second squared. And then we call the next one x2, which the train travels at a2, which is equal to negative 0.5 meters meters per second squared. Now, and these are our given data. V initial is equal to 0 meters per second. Then A1 is equal to 0.1 meters per second squared. We don't have delta T1. And A2 is equal to negative 0.5 meters per second squared. We don't have delta T2. And then we just call the distance traveled by train for segment 1 x1, and then distance traveled by train for segment 2 x2, and then x1 plus x2 is equal to 1000 meters. And then the train stops at the end, which means that v2, the final velocity, is also 0 meters per second. Now we calculate the distance traveled by the train for each segment, and we use the formula delta x is equal to v initial times t plus 1/2 of a times t squared. So if we use it for x1, since the initial velocity is 0, the first part is 0, so x1 is equal to 1/2 of a1 times delta t1 squared. And we also did for x2, which is, now we have to calculate the speed first. So let's call the initial velocity of segment 2, or the final velocity of segment 1, v1. So x2 is equal to v1 times delta t2 plus 1/2 of a2 times delta t2 squared. Now we have to calculate v1. So the formula for v final is equal to v initial plus at. Now here our v initial is 0, and then our a is a1 and t is delta t1. So our v1 is equal to a1 times delta t1, and we just substitute a1 and times delta t1 for v1 here in this formula, and we get x2 is equal to a1 times delta t1 times delta t2 plus 1/2 of a2 times delta t2 squared. And we also have that x1 plus x2 is equal to 1000 meters. So we add x1 and x2, and we will get 1/2 of a1 times delta t1 squared plus a1 delta t1 times delta t2 plus 1/2 of a2 delta t2 squared is equal to 1000. Now if you look at this equation, we do have a1 and a2, but we don't have delta t1 and delta t2. So we have two variables and one equation, so we can't just solve it yet. So we have to look for one other piece of information. And the other piece of information comes from the final velocity at the end of segment 2, which is, we just call it v2, which is equal to v1, the initial velocity for segment 2, plus a2 delta t2. Now we got a v1 from the first part here, which is a1 times delta t1, and we just substitute it here. So v2, which is 0, is equal to a1 times delta t1 plus a2 times delta t2. So a1 times delta t1 is equal to negative a2 times delta t2. And we just plug in our numbers here for a1 and a2, and we get that delta t1 is equal to 5 delta t2. Now, if we just substitute 5 delta t2 for each delta t1 in our equation, we get this. 1/2 of 0. And we just plug in our a1 and a2s also. So we will get 1/2 of 0.1 meters per second squared times 25 delta t2 squared plus 0.1 meters per second squared times 5 delta t2 squared plus 1/2 of 0.5 meters per second squared times delta t2 squared is equal to 1000 meters. And if we calculate that, if we calculate delta t2 is equal to 25.82 seconds. And we had that delta t1 is equal to 5 delta t2, so our delta t1 is equal to 129.1 seconds. And our t, which is delta t1 plus delta t2, is 154.9 seconds.